Hello everyone. We will be learning about a problem from PRMO 2012 today. This is problem number 20. But as usual, we will use this problem to learn about two concepts. The first one is sine rule of area of a triangle. And the second one is angle in the semicircle is 90 degree. You take a triangle ABC, and suppose this angle is theta, then area of triangle ABC is equals to the length of half times the length of AB times the length of AC times sine of the angle theta. What you have to understand here that this theta should be the included angle of the two sides. This theta should be the included angle of the two sides. It cannot be this one. If you have to use this theta, or let's say this is alpha, if you want to use this angle, then your formula would change. It would become half times AC times BC times sine of alpha. You can actually drop a perpendicular like this, 90 degree. So let's call this T, this point as T. So area of the triangle is half of BT times AC, right? Half base, which is AC, into height, which is BT. Now BT can be expressed in terms of AB and theta. That is the idea. So what is sine of theta? Sine of theta is opposite, which is BT, divided by hypotenuse, which is AB. So BT becomes AB sine theta. Okay. So now you can replace this BT and you get the sine rule. So this is half times AB sine theta times AC, which is precisely this formula. If you have a circle, let's say with center O and the diameter is AB, if you take any point P on the circumference, provided AB is the diameter, then this angle APB is known as the angle in the semicircle, and angle APB can be proved to be 90 degree. The proof is really simple. I can quickly sketch it. If you join OP, notice that this is an isosceles triangle because OP is a radius, OA is a radius. So this angle is theta, then this is theta. Similarly, OPB is an isosceles triangle. So if this angle is alpha, this is alpha. Why is OPB isosceles? Because OP is the radius and OB is also the radius. So the total angle of this triangle is theta plus alpha, which we know is 180 degree. That is the total angle of a triangle. So 2 times theta plus alpha is 180, or theta plus alpha turns out to be 90 degree, which is this angle, theta plus alpha. Okay, we understand these two concepts now. The sine rule and the angle in the semicircle is 90 degree. Now we will use these to solve this problem. you have a circle, or you can draw a semicircle for this purpose. Let's say we have a diameter PS. The length of PS is given to be 4. Okay, O is the midpoint of it, and you draw a semicircle like this. Okay, and then you draw a line that is parallel QR. Draw a line QR parallel to PS. Okay, and suppose X is the midpoint of the semicircle. So which means basically if you join XO, then this is 90 degree, right? So X is midpoint of semicircle. There is one more thing given actually, that is if you draw a semicircle with QR as the diameter, then this blue is tangent to PS. So this blue semicircle, it is tangent to this, or this different colored semicircle. Maybe this color is different in this video. The semicircle is tangent to PS, that is given. What do we want to find out? We want to find out the area of this particular quadrilateral. Find the area of this quadrilateral. So area of QXROQ, this quadrilateral. What is the area of it? Okay, so now it's actually quite simple. We have to just apply the two concepts that we have learned. The way we do it is, and you can pause the video here and give it a try yourself. Okay, that would be better in fact. Now the way we do it is that first realize that this is 90 degree because QOR is angle in the semicircle. Angle QOR is 90 degree because it is the angle in the semicircle, right? Because this is a semicircle, this is a diameter, so you have to see that QOR is 90 degree. Okay, now since XO is perpendicular to PS, X is the midpoint of semicircle, so if you join X with the center, that will be perpendicular to the diameter, and QR is parallel to PS, so XO is also perpendicular to QR. So this is 90 degree. Alright. Now also notice that this point would be the midpoint. Let's call this point M. This would be the midpoint. Why is that? Because if O is the point in the circumference of this particular semicircle, and OM is perpendicular to the diameter. The only way that happens if M becomes the midpoint. Okay, this is 90 degree. These two pieces are equal because M is the midpoint. This is common, which means that QMO and RMO, these are congruent. QMO is congruent to RMO, something we know now, which means that these two angles are equal. Another way to see the same fact is that OQ is the radius, OR is the radius, so these two angles are equal because it's an isosceles triangle. Okay, now we know that this is 45 degree, this is 45 degree, which basically means that in this particular triangle QMO, this is 90, this is 45, so this angle right here has to be 45 degree. Okay, so now we are in the last step. Use the sine rule of area in this triangle. How can we do that? Because we know that this is 2 and this is 2, because PS is 4, so the radius has to be 2, and OQ is the radius, OX is the radius. So the length of OQ is 2, OX is 2, and the angle right here is 45 degree. So you can use the sine rule to complete the area of the triangle and double it to find the final area of this quadrilateral. And that is the end of this problem. Can you find the value of the area? You have to just apply the sine rule and find the final value of the area, and put a comment in the description. I will check if your answer is correct or not. Okay, till then, keep on doing great mathematics, and I'll see you in the next one. Bye.